So the first half of this is completely review. Okay, so you guys remember dealing with arc, sine, arc, cosine, arc, tangent. So, whoa, I'm surprised that you guys would say that. Okay, so, okay, so kind of going like way back. I'm going to do this very quickly. So let's say you have the sine function. Oh my gosh, that was so bad. Let's redo that. I can't even teach with that example. Okay, that was a little better, but not perfect anyways. Okay, so when you learned how to do inverses algebraically, okay, the first thing you did is you switched the x and the y. Okay, and then you just solve for y. Okay, when you did it graphically, you reflected over a line. Do you remember what line it was? Y equals x. Okay, so the idea of this is if I take this function and I reflect it over the y equals x line, now assuming my drawing is not perfect by any means at all, what would this sine function turn into? If you reflected over that? Negative sign? Yeah, no. Okay, so the answer is it turns it vertical. So you have this like function that's this way. So when you reflect it, it goes like this. Okay, so you end up getting this like. That's not a very good drawing, but you get the idea. It basically turns the wave going vertical. Okay, so if you're looking at that, you're going, wait a second, that's a problem. Yeah, the pencil test. That vertical line test, you're right. Okay, so in order for the inverse function to actually exist, the math god decided we're going to restrict the domain between here and here, so therefore it does exist. Okay, so this little piece right here is the restriction so that the function does in fact exist. Okay, so this holds true for the cosine function as well as the tangent. So the tangent function, think of the tangent looks like a John Travolta dance party. Okay, so if you had a dance party being reflected over the y equals x line, you end up with like John Travolta's dancing on the side. They're like walking on the wall, or yeah, it's just not good. Okay, so first thing I'm going to show you what these look like. So arc sine is going to exist from -1 to +1, and the piece that you're going to want to remember is the y piece. Okay, so the y can only exist between -π/2 and +π/2. Did everybody hear me just say that? Because it was really important. -π/2, that part was really important. -π/2, +π/2. Got that, Matt? Cosine. Cosine goes from pi to 0. I said that backwards, but who cares? 0 to pi. You got that, right? 0 to pi. Okay, now John Travolta's, remember there was a whole bunch of vertical asymptotes? So when we turn it sideways, we end up with a bunch of horizontal asymptotes. So if we restrict this, we have horizontal asymptotes at pi/2 and -π/2, and we're just going to talk about one John Travolta lying down on his side. Okay, so why do we even care about this? Because it affects the type of answers that we're going to get. Okay, so on your unit circle, I told you to get your unit circle out. Did you get it out?
I got it out.
Okay, so this little chart here is kind of helping you put these things into the correct quadrants on your unit circle. Okay, so -π/2 to +π/2 only exists in the first and the fourth quadrant. Now, how many people have -π/2 as an angle on their unit circle? Probably nobody, I'm guessing. Okay, so the first thing that I would do on your unit circle is rewrite 3π/2 and write -π/2 right next to it. So you know that those are coterminal angles, they're equivalent spots. Okay, so at this one is 3π/2, there it is, thank you. That's equivalent to -π/2.
How's that?
Huh? Because negative pi over 2, you just go down in that same distance. They're coterminal angles. Okay, and you should have 3 angles down here. You have one that says 11 pi over 6. What's 11 pi over 6 equivalent to? Negative pi over 6. So I would write that next to it. You have, what is this, 7 pi over 4. What's negative 7 pi over 4 equivalent to? Negative pi over 4. And then the other angle down here is, what is it, 5 pi over 3? Is that what it says? Yeah. So this one's going to be negative pi over 3. Okay, so you can't use 11 pi over 6 as an answer. That is bigger than 2 pi units. So you want to use negative pi over 6 instead. Okay, so that's going to be for tangent and sine. So tangent and sine are in the first and fourth quadrant. Cosine is just in the first and second. Cosine is the one you like because that one just is straight up. It's not crazy at all. Okay, now that we have that, we're going to do this. Okay, they asked us this question. It's up to you whether or not you want to write down the answer to this or not. But can you explain why the sine of negative 1/2 is not 11 pi over 6? Or you can't have 7 pi over 6 as an answer? Right. Okay, it can only exist between negative pi over 2 and positive pi over 2. Okay, here we go. So, who remembers when you're doing arc or inverse of any kind of function, when you type it in the calculator, what are you answering? What are you finding? The angle. Okay, good. So, if you have to write that, remember the arc, see how that starts with an A? Arcs finds angles. Oh, okay. Arcs finds angles, so we're trying to find angles. All right, so here we go. So we're starting with arctangent of 1. Okay, so you're looking at your unit circle and you're thinking tangent. Okay, so tangent is the y over the x. So how can the y over the x equal 1? They're the same. So where on your unit circle? Remember, tangent can only exist in the first and the fourth quadrants. Are the x and the y the exact same value? Okay, good. So we're going to use radians. So pi over 4 is what we're going to say. So FYI, calculus, try to never think about degrees ever again. Well, I don't know, maybe not ever. It would give you, well, if you're in radians, it would give you the decimal value, pi over 4. You get your inspired. I assume that would give you a fraction number. But the 84 can't give it to you. Alright, so who's got an answer for arc cosine? So we're thinking which value? X. Okay, so where is the x? Negative 1 for the cosine. Remember, cosine exists in the first and second quadrants. What? The x value is 1. Where is the x value 1? Pi. I think you guys way overthought that. Does that make sense though? Yeah. Literally the x value is, that's all, there's only one spot. Okay, what about arc sine? So where is the y value at negative square root 3 over 2? Remember, you're only looking in first and fourth. Good. Negative pi over 3. Everybody say negative pi over 3. Okay, don't use that positive one. Last one, what is the arc sine of 2? Very good. It is impossible for an arc sine to ever be bigger or smaller than 1. No, I said that way wrong. Bigger than 1, smaller than negative 1. It can only exist between negative 1 and positive 1. Alright, let's see if you can type these in the calculator. Grab your calculator. Make a choice if you would like an Inspire or an 84. You can do it on both calculators. Sure. Okay, so first thing you're going to do is check your mode. Oh, sure. Which mode are we putting it in? Radians. Okay, so how do you type an arc in the calculator? The inverse. Okay, so you hit second sine of 0.3 and you get 305. Agreed. Everybody get that?
Yes.
Check. Okay, see if you can do an arctangent of -5/2. Inverse, so you do second. I'm not sure how you do it on the Inspire, to be perfectly honest. Let's see.
So you gotta have both.
Yeah, that's why I think that, oh, if you hit Trig, you have all your options there. It gives you the inverse button. Did you find it, Kendra? No, it's just the inverse sine of 0.3. Did anybody get -1.19 for the arctan? Did you find it? Okay. Awesome, that was easy. Okay, moving on. Ooh, okay, so now this says without a calculator, so that usually means use your unit circle if you can. Okay, so if we have an arc sine of the square root of 3/2, I grab my unit circle and I think arc sine, where is the y value? Square root of 3/2. 5/6. So then I have the sine of pi over 6. So the sine of pi over 6 is just the y value of pi over 6. The y value. Oh, then this is wrong. Sorry, pi over 3. So arc sine is where is the angle where the y value is the square root of 3/2? Right? At pi over 3.
Oh, so it's gonna just be sine of pi.
So if I'm just doing arc sine of the square root of 3/2, where is the y? The square root of 3/2.
Well, then can sine of pi over 3 is square root of 3/2.
Yeah. So did anybody find that interesting at all?
That's very interesting.
Is it the same? Like they just canceled.
It's like they just canceled, right? Yeah.
Awesome.
Isn't that a nice little trick?
Does that work?
So, almost every time. We'll do some examples where it doesn't work. Okay, so let's try the arctan or the tan of the arctan of 3. What do you think that one is? Educated guess? 3. It's 3. Because tangent goes, remember tangent is John Travolta, so it exists from negative infinity to positive, so tangent's okay, but it's the sine and the arc sine you gotta be careful of. That one has to exist between that range. Okay, so what about C? Pi over 3? Yeah. Good educated guess. Okay, what about 4? Or D, I mean. Ooh, okay, because you can't use 11 pi over 6, you have to use its negative value, so it is negative pi. Negative. Yeah, right, you just have to be careful. Walk, tread carefully.
The arc sine of that.
You can do it that way if you want. So you can do the sine at 11 pi over 6. So you would go down and you would say the y is 1/2.
Oh, I see.
Or negative 1/2. And then you would say, oh, well, where is the y negative? It's the same spot. Awesome, this is so easy. Okay, solving. Okay, who remembers how to do this? This is super duper easy, no calculator involved, too easy even for the calculator. But the first step, you have to know how to do it.
All right, show us how to do it.
So the first step, all you have to do is rewrite it. Okay, so right now it's written as an arc sine. So I have to rewrite it and get rid of the arc. Okay, so this is kind of similar to like when we converted exponential and logarithmic form. You know what I'm saying? Very similar. Okay, so the rewrite is going to be the sine of the angle is equal to this x squared minus 3. Right? It's very similar to a log, isn't it, right? It's almost like that same little trick. What's that?
Is that the same?
So, yeah, it doesn't matter which trig function you're using. You just do whatever it's equal to is what your angle is. Okay, so now this becomes very simple. I'm going to grab my unit circle. I'm going to find the sine of pi over 2. So I go to pi over 2. That's straight up. What is the y value? 1. So I have 1 is equal to x squared minus 3. This is pretty simple. I'm going to add 3. 1 plus 3 is 4. And then what? Boom. Solving arcsine, piece of cake. There is a question on the clef like that.
How often do you do that?
How often? Like on the AP test? I would say, how often? I don't know. 1 in 30. That's a guess. I don't know. I bet there's 1 or 2 questions like that, or maybe 3 on the AP test. Yeah. And it's simple. You know, like it makes sense. You just convert it. Yeah, exactly. Okay, so, last thing. Okay, so the last part of this. Oh, this is my favorite part. This is one of my favorite sections because for me it was like the, gosh, I love it when I get an O. It's not very often. Okay, so this part is the arc cosine of 2 over the square root of 5. Okay, so the first thing I think is if I see an arc cosine, I grab the unit circle and I say, okay, I'm looking for an x where it's 2 over the square root of 5. And I immediately go, wait a second, that is not on the unit circle. So I have to draw a triangle because remember, all of this is related to triangles. Okay, so here I go. Remember that this statement right here is exactly the same statement as, the cosine of x is equal to 2 over the square root of 5. Okay, so I'm thinking SOHCAHTOA. Cosine is what over what? Adjacent over hypotenuse. Okay, which you can think of it that way too. You can remember which one is your x and which one is your y.
Does it matter?
You assume that's your 0. No, you choose whatever. That one's going to be my angle. You can choose whichever. Okay, so I've got adjacent over hypotenuse, so my adjacent length is 2, hypotenuse is 5. Let's call this third side y. Okay, so how do I find the third side? Pythagorean's theorem. Okay, here's a little work down here. Y squared plus 2 squared is equal to square root of 5 squared. You pick it, it doesn't matter. Because if you're doing cosine, if I choose the top angle to be my angle, then my adjacent side will still be 2. So like the side that I have labeled y would be 2. So the ratio will still be fine. So anybody get 5 minus 4, so the square root of 1 is 1?
Maybe plus or minus.
No. Good question though. It is just a positive.
Oh, because it's y value.
Yeah.
But what if we want to do the x? That's where the x over r would.
Yeah. Unless they gave us a quadrant, we will just assume it's positive.
Okay.
So what's my tangent ratio? So tangent is opposites over adjacent. So how about anybody get 1 over 2? 1/2. That make sense?
Oh.
We haven't got there yet. Just wait for it. This is really exciting. We got like 2 more examples and then you get the O.
Alright, show us.
So see how the y value is 1? So tangent is opposite over adjacent. So 1 over 2. Okay, so number 8. This is the pre stuff for the O piece. Okay, so again, I don't have x on my unit circle, right? So I have to draw a little triangle. This is the same scenario as the one I just did. So this is equivalent to the sine of y is equal to x. Now be very careful of these variables. Which variable is representing my angle? My y. I hate that they use a y here, but we have to be careful. Okay, so sine is opposite over hypotenuse. So if sine is x, remember x is the same as x over 1. So my opposite is x, hypotenuse is 1. Right? So what's my third side going to be? A. I heard an A. Let's go with A. That works for me. Okay, so it's going to be a squared is equal to x squared. Whoop, not equal. I take that back. Plus. X squared is equal to 1 squared. So if I solve for a, we get the square root of 1 minus x squared. Okay. So if I'm asked to find the cosine of y, yes?
Wouldn't it just be 1 minus x?
No, because you have a minus in there first. By definition, you have to do the minus before you can square root it. Right. Right. Yeah, the 1 minus x squared is a quantity. Okay, so cosine is going to be adjacent over hypotenuse. So what's cosine? The square root of 1 minus x squared. Oh boy, here we go. This is getting exciting. Okay, so why do we care? Because we're doing calculus, and so we're going to do some derivatives with this stuff, naturally. So example 9 is going to walk us through taking the derivative of the arc sine.
This box first.
Arc sine.
Derivative of arc sine. We're going to get to that. We're not there yet. You're too far ahead.
There you go.
Okay, so remember that we just said y is equal to the arc sine, right? So we're using example 8 to help us. Okay, so if I rewrite this, bless you, we have, unless you know how to derive this at this point, you can't do it, so we're going to rewrite it. So we would say the sine of y is equal to x. Okay, so now that is something that I can derive. Okay, I can derive it with implicit differentiation. Okay, what is the derivative of sine? Cosine. So this gives me the cosine of y, and since I just derived a y, what do I have to multiply by? dy dx, dy dx. And what's the derivative of x? 1. Dx dx, but I don't have to say dx dx because that is 1. Okay, so then if I solve for dy dx, divide by cosine of y, 1 over the cosine of y. Okay, and my last step here is I'm going to steal this piece that cosine of y is equivalent to. See that? So the cosine of y is square root of 1 minus x squared.
Right there.
So if you turn your book over, the arc sine is... That's a good point, but today you can't. Isn't that crazy? I always wondered that because I was always just given the fact that the arc sine is this, and I thought, well, where the heck did I get that from? That makes no sense at all.
Where did they get
It all comes back to the right triangle. The Pythagorean's theorem. Oh. Gosh, that was good. No, we did it. We're there. That was it.
You missed it, Hunter. I kind of missed it. Can we go back? I want that all.
There it is. It's right there. Oh, that is it. See, for me, I was like, oh. I had always wondered where that came from. Because I was always just given this box of information, and I just memorized this box of information, and I never knew where that derivative came from. And I thought, well, that just makes no sense. So now it makes sense, right?
Say it says to take the derivative of a different function. Can you just set up a triangle? Throw that in?
An arc? If it's an arc, yeah.
Oh, right. I like that. Oh, if we're gonna do that.
Isn't that good, you guys? Oh, that's good. Okay, so take a quick look. Now, at this point, it probably is more valuable to you to just memorize this. I will tell you that if you were going to take the CLEP, this literal definition is on it. Like, it literally asks you what is the derivative of the arctangent.
Is it the same test over and over again?
I think it is, but I'm not 100% sure. I guess we'll find out when somebody else takes it besides me. Yep, I have 5 that are in the other class. 1 in this class.
Who's the other one?
Who is going to take it in the other class?
Yeah.
Tyndall, Bethke, Haley, Wisner, Tanner, Campbell, Doug McLeod, and someone else I can't think of. Here, Nathan is taking it. So there you go. Anyways. Okay, so let's do this. Let's practice the actual calculus of this using our definitions now. Okay, so remember that we're deriving. Okay, so remember if there is something after the u piece, what are we going to do with it? Derivative. Multiply. Okay, so if I'm dealing with a fraction and I multiply by something, am I going to put it on the top or am I going to put it on the bottom? It goes on the top. Okay, so that's where these other definitions come from. It's not any different than any derivative that we've been doing. You are simply multiplying by the hook-on factor. It just goes onto the top. Okay, so that's kind of a thing that you should be realizing at this point. If I'm deriving, I multiply by the hook-on factor. If I integrate, I divide by it. Okay, all right, here we go. So for number 10, can I go just straight to the answer on this? What's going to go on the top? What's the derivative of the u piece? 2. And then I'm going to have, since the derivative is 1 plus u squared, I'm going to have 1 plus 2y minus 1 squared. The derivative of 2y minus 1 goes on the top. Fill in the pieces. Very literal.
How did you know what was u?
The u is the stuff that's after the arc sine or arc tangent or arc cosine.
Oh.
So if it's not an x, that's your u. Are we good there? Too fast? That was actually really easy. No? You just have to like pay attention. Okay, number 2, or 11. Okay, so remember that the square root of x is the same as 1/2, right? X to the 1/2. Okay, I'm just going to write that because I think that's helpful. Okay, so I'm going to start by saying, okay, my u is x to the 1/2, so I start by deriving it. What's the derivative of x to the 1/2? 1/2 x to the negative 1/2. And then for sine, I would do 1 minus my x to the 1/2 squared. So now this one can be simplified a little bit, right? That's the definition. Remember we just went through that? Remember the O? This was only valuable to me. It was only an O for me.
Actually more of an
Ah, okay. Good to know. Okay, so if I rewrite this, I have 1/2 in the top. I'm going to put the 2 downstairs, but I have a x to the negative 1/2. What am I going to do with that x? Put it downstairs. So what's left in the top? Just a 1. So I have 2x to the 1/2 square roots of 1 minus x. Can I just say 1 minus x, right? Because I have the 1/2 times 2 down there. Done. So this is not a great answer. I don't like it a lot because I have an exponent with a root written as the answer. So probably in a multiple choice scenario, you would either see only roots or only exponents. So they probably would write 2 square roots of x times the square root of 1 minus x. Which you could even go further with. The 2 1/2s. Are you talking about the x that says x to the 1/2 squared?
Yeah.
Yes, because you multiply those, right?
Square root.
Yeah, square root squared. Okay, number 12. So we got an arc cosine. Okay, so this is just going to be my arc cosine rule. So my u is the natural log of t. Let's see if you remember this. Oh, very nice. So the derivative of natural log is 1 over t. So I'm going to do, oh, and cosine is negative, right? So I would do negative. Is that what you're yelling at me about? Good. Minus the natural log of t squared. Now do notice the way I wrote the natural log part. Notice that I put the natural log of t in parentheses, then squared. If you don't write parentheses, it is a different expression. Okay, because the t would be squared. That's different instead of the 2 natural logs. Okay, so rewrite on this one would just be negative 1 over, we'll just throw that t downstairs. Very
So
simple.
would they ever put right above the
Say that again. The 2 with a log?
well, no, you change sine function because on the change you bring that to that's right.
Yeah, yeah.
And
Mhm.
outside with a different notation, the LN
Nope. Nope. They'll always put it on the outside with an LN. Yep. All right, here's your assignment. 1 through 26. And don't forget to do number 33 too. Okay, so even though this one has more problems